Okay, on the last video here, we're going to be looking at a right triangle. Here we have a triangle RQS that's a right triangle, and we can see its angle Q, that's the right angle. It has the symbol for a right angle there showing us that it is the 90-degree angle. So what we're going to be looking at is what is special about the sum of the other two angles. Remember, sum just means to add them together. And so right here we're given the angle measures for the other two angles. Remember, when you're given 3 letters to name an angle, the middle letter is the vertex. So when it says measure of angle QRS, it's talking about angle R, and the measure of angle RSQ is talking about angle S. So we're wanting to look at their sum, and so I'm going to just click this box to show the sum of those two, and you can see right now that they're adding to be 90 degrees. Well, if I change this triangle, but keep it a right triangle, but if I just change the measure of angle S, by moving that, do you see that the sum is remaining 90 degrees? Same thing if I change where angle R is in the drawing. Changing its measure, is it changing the sum of angle R and S together? And you can see it's not. And so all this is showing us is that if you have a right triangle, then the other two angles are both going to have to be acute because they have to be less than 90, and they're going to have to add up to the remaining 90 degrees of the whole sum. Since we know they all add to 180, if this one's taking up 90 degrees, the other two have to make up the other 90 degrees. And so remember, that means that they are complementary angles when the two angles have to add to be 90. So the acute angles of a right triangle have to be complementary, is what we're looking at in that animation. So let's look at the answers to 8 through 12 in your notes here. So first of all, what do we call two angles that have a sum of 90 degrees? Remember, the term for that is complementary with an E, not an I. And it always has to just be two angles. So if you have a right angle, it is not a complementary angle. It is by itself the full 90 degrees. It's when you have two angles that add up to be that right angle that they're complementary. But remember, they don't have to be adjacent to each other. They can be two angles that are separated from each other but have a sum of 90. So those are any two angles that have a sum of 90. If it's 3 angles that add to be 90 degrees, they're not complementary. It's just 2 angles. So we're going to write a conjecture based on the animation we just looked at about the acute angles of a right triangle. So we just learned that angles R and S always added to be 90 degrees, or in other words, they are complementary. So our conjecture is that the acute angles of a right triangle, it only works for a right triangle, are complementary. And that's because the right angle is taking up 90 of the 180 degrees, leaving us with 90 degrees total for the other two angles. So we're going to prove that conjecture in number 10 on your notes. We are given a right triangle. We're given the one from our animation where Q is a right angle, and we want to prove that angles R and S are complementary to each other. So we are given the fact that angle Q is a right angle. It says with a right angle at Q. So that was given, and we're using the definition of what our right angle is to say its measure equals 90 degrees. So in our next one, it has 3 angles that are adding to 180 degrees, and that's the 3 of the triangle. We know that always the 3 angles of a triangle add to 180 by what theorem? It's on the front of your notes, by the triangle sum theorem. Remember, it's a conjecture that we've proven now. So anytime we use it in a proof, it is now called a theorem, and it's called the triangle sum theorem, that the 3 angles of a triangle add to 180. Now we have to fill in the missing one. We have angle Q, angle R, so the missing one would be the measure of angle S. So in the next one, we're going to use substitution. Notice we still have R and S in that same equation. We're replacing the measure angle Q with something. Well, we can only use substitution if we know it's equal to something. Well, we know in number 1 that the measure of angle Q is equal to 90 degrees. So I'm going to replace the measure of angle Q with 90 degrees, since those are equal. So now our next step just has the measure of angle R and S on the left side of the equation. So obviously we got rid of the 90 degrees. We got rid of it using subtraction. So we subtracted the 90 from both sides of the equation, keeping it balanced. So now we only have the measure of angle R plus the measure of angle S on the left side. And what would we have on the right side when we subtract 90? We would have 90 degrees remaining. That's using the subtraction property because we subtracted 90 from both sides of the equation. So now that we know those two angles add to be 90, we have a name for that. Two angles that have a sum of 90 degrees are called complementary angles. So we know that R and S, those angles are complementary by the definition of what complementary angles are. And there is the proof of that conjecture. Let's look at the remaining questions on your notes here, 11 and 12. Number 11 just reminds us that an obtuse triangle is a triangle that has just one obtuse angle, which remember is an angle whose measure is greater than 90 degrees. If it's exactly 90, it's a right. If it's bigger than 90, it's obtuse. Remember, a triangle can only have one obtuse angle, because if it had two angles that were more than 90, you've exceeded the 180 degree sum. So if you have an obtuse angle, what has to be true about the other two angles of the obtuse angle? So if you have one angle taking up more than 90 degrees, could the other two angles be supplementary? Well, angles that are supplementary add to 180, so it wouldn't make sense for two of the angles of a triangle to add up to be 180, and then the third one to be more than 90. You are way over your 180 degree sum there. So that is not a correct answer. Says both angles must be acute. Well, if you've gotten more than 90 degrees of your 180, that means you have less than 90 degrees left for the other two angles. So yes, that makes sense that they both have to be acute. They have to be less than 90 each. C says at least one of the angles must be right, and that would not make sense. If you have one angle that's more than 90, one angle that is 90, you're already above 180 and you haven't even gotten to your third angle. So that's impossible. You can't have an obtuse angle and a right angle in one triangle. D says the angles could be complementary. If you have one angle that's more than 90, could you have the other two adding to be exactly 90? And no, that's impossible because they would be over the 180 degree sum if the other two were adding to be 90 and you had one angle that was more than 90. And we've already talked about how the other angles could not be obtuse as well. Okay, so if you have one obtuse angle in a triangle, then you know that the other two angles have to both be acute. They have to be less than 90 each. If this one is more than 90, like if that one's 101, obviously those have to add up to be 79 degrees, which makes them both acute. And number 12 is a true-false. If two angles of a triangle are congruent to the corresponding angles of a second triangle, then the third angle of the first triangle is congruent to the third angle of the second triangle. So let's make sure that we understand what in the world this is asking. So if I have two triangles, and I know that, I'm not drawing them very well, but just go with me. This one is 100 degrees, and this one's 100 degrees, and this one's 30, and this one's 30. Then we are doing what the first part is saying. Two angles of this triangle are congruent to two angles of this triangle. What it's wanting to know is that, does that mean that the third angle of each of the two triangles are congruent as well? And of course that would have to be true. Since the sum has to be 180, if these both have a sum of 130 with the first two, then that leaves 50 degrees for both of them in the third angle. So yes, if two angles of one triangle are congruent to two angles of the other, then the third angles have to be congruent as well. Alright, good luck on your homework, and remember, I can see you in tutoring in the morning if you need help.